Hi everyone, my name is Alex Levy and I'm a rising fourth year at the University of Chicago majoring in mathematics. My research this summer with the CDAC Summer Lab was on how to combat misinformation on Twitter using natural language processing and graph structures. So before I begin with my presentation, I want to set a little bit of terminology. So disinformation means outright falsehood that is deliberate and intentional, whereas misinformation is misleading and sometimes false information that is spread either intentionally or unintentionally. So there's actually been a lot of existing literature and programs that people have written to detect outright disinformation, usually targeting it at the source. For instance, I read a couple of studies where the developer had used classification machine learning algorithms to detect disinformation bots on Twitter. And usually how they determine the classifications with the test data is either they crowdsource to fact check or they have journalists do it. Now, what's a little bit more nuanced is actually detecting misinformation, which, as I said, can be unintentional or just misleading and not outright false. So, as I was designing this project with Professor Nick Feemster, one thing that we ran into is we don't want to be the arbiters of truth. Human lived experience is actually quite subjective. So sometimes it's very hard to classify misinformation. So, as a result, the motivation for this research was to create a algorithm that can help detect structural patterns in both semantics and information flow. So the first step in taking on this project was to learn about machine learning, including unsupervised natural language processing. I downloaded the GenSim and scikit libraries to write an algorithm that pre-processes text and finds text clusters based on the input of one or more CSV files. So I got the data, these CSV files from a GitHub repo on political sentiment from various world leaders. So the technique I used for natural language processing is called LDA. The way that LDA, or latent derelict analysis, works is it's a probabilistic model. And so in order to assign clusters, it uses primarily two probability values. The first being the probability of a word given the topics, and the second being the probability of topics given the document. And so these values are calculated based on an initial random assignment after which they are repeated for each word in each document to decide their topic assignment. We wait. And continue waiting. And here we go. It gives us clusters. One article that I read on Medium actually said that interpreting unsupervised NLP is a little bit like reading tea leaves. So we're consulting an expert on the next steps for the NLP. And the next step after that is graph structures, particularly linkages between user and domain. So I'm going to demo this graph algorithm for you. So as you can see, on the left, we have users. On the right, we have sources that they're linking to. In this particular case, we put in 6 communities for the eigenvector algorithm to split it into. It seems as though 6 might not have been the right amount because I don't think these results look particularly meaningful. However, it is another parameter that we can set. And as we go about attempting to detect patterns, specifically once we start incorporating semantics, it will be useful to see there might be 3 or 4 main fields of sentiment or fields of information flow that we would like to split this into. So it's good that we have this modularity. As we all know, research is an ongoing process. So I think that my findings from this summer have told me what some good next steps for this project might be. A few things. Number 1, utilize a high-speed server to run these algorithms on enormous COVID stream data sets. 2, consult an NLP expert for better consistency metrics and word vector concatenation techniques. And 3, investigate strategies to integrate semantics into network structures. This has been a very fruitful summer, and I've learned a lot about particularly machine learning, graph theory, and the Twitter API. I hope that as I continue to work on this research into the fall, I can continue to craft this algorithm into something that truly can provide insights into where we can look at how misinformation might spread. Thank you.